Alright, so 9.5a, what we did leading up to this is the non-juniors talked a little bit about adding, subtracting fractions in general. So these problems at the top are problems that you should be able to do. When you have a common denominator, you just add the tops. So for this problem, I would just add it and get 5/7 and be done with it. For this problem though, I don't have a common denominator. I'll get back to that. Let's look at number 3. Again, common denominator, so I just subtract the tops and get 3/5 and be done with that. For these two problems that don't have common denominators, I can do one of two things. Find the least common denominator, or just find any common denominator. Either way, I can just simplify it towards the end. So for this, the least common denominator for 9 and 2 is 18. And remember what you do here is whatever is missing, 9 times 2 is what I got to do to the top as well. 2 times 9 gives me 18. I got to do that to the top, and when I add them, it's just adding the tops to get me there. Same kind of thing with subtraction. I'm going to use 6. I could use 18, and then I just have to simplify it, but instead, this is already simplified. This I can just times by 2, do the same to the top, subtract, and get 1/6. Okay? So, when you're adding subtracting rational numbers with the same denominator, we simply just add or subtract the tops, which are called the numerators. We never add the bottoms. 1/2 plus 1/2, a half a pizza plus a half a pizza equals a whole pizza. It doesn't equal 2/4 of a pizza. Okay? When you have to add or subtract with different denominators, though, we need to find a common denominator. Now, in dealing with these problems with polynomials, which the next page really has more to deal with than this page, we got to do the following things. The first step is to factor each denominator. I'm going to have you do a little of that today, but we're really going to touch base more on that. Denominator. We're really going to touch more base on that in the second day of our notes on this. The next step will be to multiply the numerator and denominator. A lot of people remember to multiply the denominator. Sometimes we forget about the numerator, okay? Of each fraction by what's quote-unquote missing. This will make sense when I get to the second part of these notes, okay? In each term to create one common denominator. And then our last step here, after we have a common denominator, is just to go back to what we would do from the beginning. Add or subtract the numerators. Simplify if possible. And you'll see what I mean by that here in just a second. Now, we have restrictions here. Remember what the restrictions mean. We put this here separate. Restrictions. What do they mean? They mean that the x value makes the expression undefined. Okay, we talked about that. So, for this first example here, and I would just be doing 1, 2, 3, I'm going to have you guys do 4, 5, and 6. We have a common denominator, we can just add the tops. I get 6/8a. Now, of course, that can be reduced because I can divide a 2 into each of those and get 3/4a. The a just kind of comes along as a ride. Now, in this problem, we don't have a common denominator. So I want to ask what's missing. For 3 and 6, the biggest number they'll both go into is 6. Okay? So let me start there. I got a little ahead of myself with that b. But the biggest number that b and b squared will both go into is b squared. So this one's actually all set. What's missing here to get me to 6? Well, I have to times by 2, and I have to times by b to get b squared. So I do the same to the top, and I get a 4b, I get a 1. And when I can't combine them, which you can't combine 1 and 4b, you just write 1 plus 4b. And I'm going to put it all over 6b squared, and I'm done with that problem. Okay? Next problem, same thing. Let's restart this here. What is my common denominator? Well, for 4 and 5, the lowest number that they each go into is 20. I got an x and a y, so I need to have an x and a y for both of those. What's missing to get from here to here is to times it by 5 and y. What's missing to get it from here to here is to times it by 4 and x. So I'm going to do the same to the top. 15y, 8x, and then literally just write it out as 15y minus 8x over 20x y, and be done with it. Okay? I want you guys to try the next 3, and so press pause and come back and check your answers when you're done. Okay, so check your work. You can see what I did here. If you press pause, you need to stop at a problem just to copy stuff down and do that. But this is kind of day 1 of these notes, is just working with monomials in the denominator and what's missing in each of them. Then I'm going to have you go to the next page as well and just have you factor the problems for 7, 8, and 9. Okay? Your homework then will be just 1 through 6 and to factor the denominators of 7 through 9. Okay, I'm going to do that right now and kind of continue with these notes so you understand what day 2 entails. Okay, so day 2, the first thing we're going to do is, you'll already have hopefully done these, but I'm going to show you anyway. To factor this denominator is x plus 4, x plus 1, and this one is 3 times x plus 1. Okay, I'm just going to keep going by just factoring the denominators. This becomes 3 times x plus 5. This, I can factor a 3 out of there first, because it makes it a heck of a lot easier. I said always try and see if you can pull out a GCF first, because now this becomes 3, x plus 5, and x plus 2. Okay? On number 9, I can factor each of those denominators. Again, I can pull a 5 out of each of those. Makes it a lot easier, because that makes it 5 and x plus 5 and x minus 5. I can factor a 3 out of each of these to get me there. So I'm going to kind of write those out so that we see what I got. Okay. Now, to find a common denominator for both of these, again, I'm going to go like this. I need to see what's missing here that I have here. Well, I have an x plus 1 in both of these. I have an x plus 4, which I don't have here. I'll get to that. But what's missing is this 3. If I need a 3 there, I got to do it the same to the top, and I get 3. What's missing here, I have a 3, I have an x plus 1, I don't have an x plus 4. So I have to do x plus 4 to the bottom and x plus 4 to the top. Now what you can see here is, I can kind of put a plus sign here and make that one long fraction, because now I have a common denominator. There it is. Now, what I have to do here, of course, just distribute. So I've got 5x squared plus 20x. And then I'd like to just write it in standard form, but if you wrote it like this, I would take it, I would accept that as an answer. 5x squared plus 20x plus 3 over 3, x plus 4, x plus 1. I do want you to do the work on the numerator in order to simplify things, but the denominators can stay as factors. I'm okay with that. Let's look at number 8. Similar type of problem. Let me write one giant fraction bar here, because what am I missing here that is here? And this, that x plus 2. So I need to multiply the top and bottom by x plus 2. What am I missing here that's here? Nothing. I've got the 3 and the x plus 5. I got the 3 and the x plus 5. So my common denominator is 3, x plus 5, x plus 2. On top, I need to distribute this first. 4x squared plus 8x, and then plus 1, because I didn't do anything over there. And that's it, ladies and gentlemen. That's my answer, just like that. Same thing here. I'm going to put a big fraction bar. What's missing here that's here? Well, I have the x plus 5, but I don't have the 3, so I need to times this by 3. I get 21x minus, well, I'll get to that. What's missing here that I have here? Well, I need that 5, so I need to times it by 5. And I need the x minus 5. Okay, so I need to first multiply this as 20 and then distribute that through. So this is, by the way, because of this, a negative 20 that's being distributed. So I have negative 20x plus 100. This is about as hard as it gets, but it's really still not that hard. I know what my denominator is 15x plus 5x minus 5, but I'm going to combine my like terms first before I start writing that all out. 21x minus 20x, of course, is just 1x plus 100. If you were doing this problem, you got minus, it's because you forgot to distribute the negative into the negative to make it positive, over 15, x plus 5, x minus 5. And that's the answer for that one. Here's where I want you to pause it. I want you to try the next 4 problems and come back and check your work. All right, so as I do this, again, I'm just going to go through and start factoring here. So again, all I did is go through and just factor those. And again, when I do my common denominator, I'm going to write one long fraction bar. And what do I need here? I need a 4 here that I don't have. So I need to times that by 4. And that's it, because those are still there. Over here, what's missing? Well, I have the 4 and the x plus 2. I need an x minus 6. So I do that to the top and bottom. Now my common denominator is right there for me. I distribute here, I get 4 plus, distribute there, get 3x squared minus 18x. And I'm good enough with that. If you can write it back in standard form, great, but you don't have to. I'm good enough with you leaving it like that. Okay? Next problem, same thing. I've got, let's see, put my long fraction bar here. This is a plus problem. What's missing here from there is just the 3. So I get 3x plus, what's missing here that's there is the x minus 2. So I need to distribute that and get 7x minus 14. Now again, I can combine some like terms here before I rewrite this whole thing and have 10x minus 14 all over 3x plus 2, x minus 2. Okay. See, I'll write this out here. I've got a minus, so I got to be careful a little bit here, but what's missing that's here and not here is times a 2 to get me to 6, right? So I got to times that by 2. What's missing here is the x plus 7, so I got to do that too. Now again, this minus really gets attached here as a negative by zip zap, and then I know that I'm distributing a negative 3x here. So I'm going to have 4 minus 3x squared minus 21x. And again, I could rewrite this in standard form, but I'm not even telling you you have to do that. There's my answer. What's missing on each of these here? I've got a 3 in both. Good. Here I've got an x minus 2. Here I've got an x plus 2, so I need an x plus 2 over here. And I got to do that to the top as well. And then the x minus 1s are the same. What's missing over here? I've already got the 3. I need an x minus 2. And this becomes a little complicated. Here it's not so much. I can distribute x squared plus 2x minus, well, this is all of that FOIL together. So I'm going to FOIL it. I'm going to write it as a minus problem. Minus 2x squared minus 4x plus 1x minus 2. I'm going to simplify it before I do anything here. This is negative 3x, so I'm going to kind of make that go away. And then I'm going to distribute a negative 1 into every term, okay, because this really is a negative 1. So I got x squared plus 2x minus 2x squared plus 3x plus 2, and then combine my like terms, okay? So I've got 2x squared terms gives me negative 1x squared plus 5x plus 2 all over 3 times x plus 2 times x minus 2 times x minus 1. Now, it doesn't really matter the order in which you write these on the bottom. If you wrote x minus 2, x minus 1, then x plus 2, that's okay too. And that's it. That's the assignment, okay? You will have done 1 through 6 on the first day of this, 7 through 16 on the second day, so you should have all of 1 through 16 done by day 3, and I'm going to have you turn this in, and I'm going to check it from there. So, have a good day. Again, 1 through 16 total is the assignment for this entire thing. 1 through 6 on day 1, 7 through 16 day 2.